Hello, everyone. To finish off bonding, I am going to talk about formal charges and resonance structures. Let's do formal charges first. So, formal charges help you determine the best Lewis structure that a compound can have. How do we know how to calculate the formal charge? Well, the formal charge is depending on each element. And for that, we say that the formal charge is equal to the number of valence electrons in that element minus, and then we have this sum, the sum of the number of bonds around the element plus the number of electrons around the element in lone pairs. So this is the Lewis structure for ammonia. Notice how nitrogen has 3 bonds and 2 electrons. So to calculate the formal charge of nitrogen, we use this. Nitrogen has 5 valence electrons, 3 bonds in this structure, and 2 electrons, so 2 extra electrons. So 5 minus this sum gives you 0. This is how you know this is the best Lewis structure for ammonia. Let's look at PCl5. In that Lewis structure, and you can go back to my last video, and you can see that phosphorus has 5 valence electrons, and in this particular structure, it has 5 bonds and no extra electrons. This minus that sum is equal to 0. So that Lewis structure is the best Lewis structure for PCl5. But what if we had a polyatomic ion? Let's talk about phosphate for a bit. So this is how we would want to draw phosphate, correct? But then we have to use the formal charges for each. So if we look at it, phosphorus has 5 valence electrons, and in this particular structure, it has 4 bonds and no extra electrons. So 5 minus 4 gives you 1. Now each oxygen in here, it's the same, so I'm only going to do it once. Each oxygen has 6 valence electrons, and in this structure, they have 1 bond and 6 extra electrons, giving each of the oxygens a formal charge of -1. So this is based on those formal charges, this is that Lewis structure. And in total, we get that -3 ion, like phosphate should be. But notice how each element has a formal charge. The best Lewis structure minimizes the number of formal charges in a compound. So what if we draw it this way? Let's compare the two. Notice how this Lewis structure down here has a double bond, right? 2 bonds with this oxygen, but this one up here doesn't. This is perfectly okay because it now minimizes the number of formal charges in that compound. So if we do it for each element, phosphorus, 5 valence electrons, and now it has 5 bonds. 5 bonds, 0 extra electrons. So that gives you 0. The oxygen without the double bonds, right, stays the same as before. And they just have 1 bond and 6 extra electrons. Gives you -1. But then that last oxygen with a double bond, 6 valence electrons, it has 2 bonds and 4 extra electrons, that's 0. So if we compare the two, this Lewis structure down here has 3 elements with a formal charge, but this one has 5. So the Lewis structure down here is the best way to draw it. But notice how I drew the double bond here. It doesn't have to be there. It could be here, it could be up here, or it could be on this one. And we will show those using resonance, but more on that in a bit. Now sulfate. If we were to do sulfate, this is how we do the Lewis structure for sulfate, right? And you guys could do the formal charges on your own, so you could practice. And you will get that there are only 2 elements with a formal charge. But same deal as before. The double bond doesn't have to be there. It could be there, or there could be different combinations of where the double bonds are. And this is where resonance structures come into play. So resonance structures show the different structures for molecules that have double or triple bonds. And I'm going to use sulfates because it has more resonance structure than phosphate. So I drew it the way I had it up here, with the 2 double bonds there. But then notice how I'm switching it. Notice how these 2 on this next structure are now these 2. So that's 1 resonance structure, or 2 different ones. And then we change it for it to be up and to the left, up and to the right, down and to the right, and down and to the left. So all 6 of these different Lewis structures show you the different ways that the double bonds could be arranged, right? They don't have to be in just one like I have it up here. They don't have to be just there. They could be around in different elements. And we do this to show that the double bonds are actually moving and they're not staying in one exact spot. So meaning at 1 second it could be this structure, the next one it could be this one, then it could be this one down here. So the double bonds are moving between each of these elements. And this is all for resonance, and this is the ending of bonding. Thank you.